Hi, my name is Cami Thompson, and I tested the equivalence points of 3 fruits: apples, lemons, and grapes. To understand why each fruit has a very unique equivalence point, we have to look into the most common acids of each fruit. Apples are known for their high content of malic acid. Malic acid's molecular formula is HO2CCH2CHOHCO2H. When we simplify this molecular formula, its empirical formula is C4H6O5. This empirical formula is a formula you might see more commonly. The structure of malic acid is fairly simple. It includes 2 double bonds to the oxygens. Keep in mind that the points on the structure represent carbons. The molar mass of malic acid is 134.09 grams per mole, which is low compared to the other acids we will be learning about. There are several characteristics that make malic acid unique. While there is a large amount in apples, malic acid naturally occurs in all fruits. Like other organic acids, malic acid is a weak acid. This shouldn't be a surprise since we easily consume fruit with malic acid in it. This acid contributes to the sour flavor in fruits and is even used to make candy taste sour. It has a high solubility rate, a lower melting point than many other acids, and can even be used as a buffering system in our body. It stabilizes pH to control the gel texture seen in many fruits around us. Like I said before, malic acid is a weak acid. Organic acids are usually weak. We can eat these acids safely because of it. These weak acids can act as a buffering system within our body because of their small dissociation contents. Keeping these small dissociation contents in mind, our pKa for malic acid is 5.097 and our Ka is 8 times 10 to the negative 6th. The next acid we will take a look at is citric acid, commonly found in lemons. Its molecular formula is C6H8O7. Citric acid structure has 3 double bonds to the oxygens. Remember, each point on the structure represents a carbon. Citric acid's molar mass is 192.24 grams per mole, the highest molar mass of the acids we are talking about today. Citric acid has several characteristics that make it unique. As you can probably guess by now, citric acid is a weak acid. It comes in crystalline white solid structures, and it is stronger than other carboxylic acids. It also has buffering properties because it can absorb hydrogen ions without changing the pH. It emulsifies fats like the agents that keep oil and peanut butter mixed together. Citrates, the salts of citric acid, have natural calcium chelating properties which help to prevent clots. This means that they are able to bind excess calcium in your blood and remove it from your body. Like I said before, citric acid is a weak acid. Most organic acids are weak. We can eat these acids safely because of it. These weak acids can act as a buffering system within our body because of their small dissociation contents. Citric acid's pKa is 6.396 and its Ka is 4.02 times 10 to the negative 7th. On to our last acid. Perhaps the least common of our acids, although still seen in many foods, is tartaric acid. Tartaric acid is abundant in grapes and wine. Its molecular formula is C4H6O6. We can see that tartaric acid has 2 double bonds on its oxygens. Remember, the points count as carbons. Tartaric acid's molar mass is 150.087 grams per mole. It shares several characteristics with malic and citric acid. It is a weak organic acid as well as occurring as white crystalline structures. Tartaric acid is a diprotic acid. It also emulsifies fats. It's commonly used in cooking, often as a leavening agent when combined with baking soda and as effervescence for water. And as I said before, tartaric acid is a weak acid, as most organic acids are. Tartaric acid's pKa is 4.366 and its Ka is 4.31 times 10 to the negative fifth. In my demo, to find the equivalence point of freshly squeezed fruit juices, I used the process of titration. I used a colored indicator of phenolphthalein. My first test was with apple juice. It took 2.5 milliliters of NaOH to reach the equivalence point of about 8.5. This test proved that apple juice was the least acidic out of the three juices. My second test was with lemon juice. It took 22.7 milliliters of NaOH to reach the equivalence point, much more than apple juice. The pH then read to about 9 using the pH strip. My third and final test used grape juice. 3.7 milliliters of NaOH was used in order to reach an equivalence point of between 9 and 10. Here are the used pH strips laid out at the end of my 3 trials. Very pretty as well as informational too. And here are my sources. Thank you for watching and have a fantastic summer.